Alright, so chapter 39 is about recursion, and recursion is where you have a, let me go ahead and drop it here. Recursion is where you have a method that calls itself. Right? That's all it is. It's pretty simple, but in practice it's not so simple. So let me give you an example here, and going over this one example, you can kind of use the same strategy for other examples or other problems in the book. And so what do we have here? We have in main, sum is being called, the result is being stored in result, and it's being printed out. We can make it even more simpler by going ahead and running sum inside of the system print line. We're giving it the number 10. It's going to come over here to sum. It's going to run it. K is going to be equal to 10, and then it's going to do this if else, right? Now, I wouldn't want to say every, but most recursive methods, they have an if case and they have a else case. And so one of those cases is going to be the return case, right? And usually, yeah, we have it's called the base case, but actually in this example there's actually two returns. So why don't we just skip what I said there and keep on going. So if k is greater than 0, then it's going to return this number here, and if k is not greater than 0, then it's going to return 0, right? But notice on the first return we have a call to sum as part of the equation, or part of the expression, right? So the first time it comes through and calls sum, it calls it with 10, right? 10 is greater than 0, so it returns 10 plus sum of 10 given 10 minus 1, which is 9, right? So in order to calculate this expression here, we need to first run sum, right? So I'm going to go ahead and signify that we run sum by putting this down here. Okay. Okay, so we're there. But now we're not running sum with 10, right? Like we did in the start. We're running sum with 9. So this is not going to be 10 anymore. It's going to be 9. This is not going to be 10 anymore. It's going to be 9. This is not going to be 10 anymore. It's 9. This is not going to be 9 anymore. It's going to be k minus 1, which is 9 minus 1. Right? So this is 9 minus 1 is 8. Okay. Well, this is true. So it's going to return this expression. But in order to return this expression, it needs to run sum given 8. Right? So we need to call sum again. And I'm going to signify that by pasting it down here. But this time we're calling it with 8. Right? And then that means this is 8, this is 8, and this is 8 minus 1, so it's going to be 7. But, you know, this is the if is true, and then we need to return this statement, but to return that statement we need to return sum of 7 first. So we need to call sum using 7. So it keeps on going down, 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 down the line, okay? And so I'm just going to go ahead and quickly put this together. So we got 7, 7, 7, this is 6, and then we're going to call sum again with 6. So I'm going to put it down here. I'm going to call it with 6, and this is going to be 6, 6, this is going to be 5, and then I'm going to call sum again, but this time I'm not calling it with 6, I'm calling it with 5. That means this guy's 5, this guy's 5, this guy is 4. Bear with me here, I should have started with a smaller number, but I just copied and pasted the example, so just hold on. We got 4, 4, 4, and this is 4 minus 1 is 3, and then we're going to keep going until the else is hit, right? And the else hits when k is not greater than 0, when k is equal to 0. So we're almost there, just bear with me here. So this here is a 3. We have a 3, 3, and a 2. Got a couple more calls here. We got 2, 2, 2, 1. We got one more call down here, and it's going to be 1, 1, 1, and then now I'm calling it with 0. Alright, here's where it gets interesting. So now I'm calling sum with 0, right? So it's going to come over here, it's going to call sum with 0, and then 0 is greater than 0. That's not true, so it is not going to do that. It's going to do the else, right? And on the else, it's going to return 0. So we're not returning an expression involving sum anymore. It stopped recursing, right? So this is the regular case. I'm not sure what it's called, but it's I'll call it the regular case. And then this here is what we call the base case, right? So we hit the base case. No, I'm not sure. Not regular case. This is gonna be a recursive case. we hit the base case, so we no longer need to call sum anymore, right? Which is good, because now we can just return 0. But return 0 where? We return 0 back to where sum was called, where we were given 0, right? And so where was sum called, where it was given 0 as an argument? It's right here, right? And so what does the return do? It returns back to where the method was called and replaces the method call with the return value. In this case, we hit the base case, the return value is 0. So we're up here and we're returning 0. Okay, so we hit the base case, we return a value. Now we can do this math here. 1 plus 0 is 1, and we are returning 1. And where are we going to return 1 to? We're going to return 1 to where sum was called and where it was given 1 as an argument, which is namely right here, right? So we're going to take this value 1, and we're going to replace the method call that got us down to here with the return value of 1. So I'm going to go ahead and delete sum 1, put a 1 there. Okay, so now we're up here, and we could do the math. So we do 2 plus 1 is 3, and we return 3. And where do we return 3 to? We return 3 to where sum was called and where it was given 2 as an argument, which is right here. All right, so I'm going to go ahead and replace that with my return value of 3. Do the math, I get 6, and then I return 6, right to here. So replace that with 6. I do the math, that's 10, and then I return 10 right to here. Okay. I do the math, I get 15, and then I replace this call to sum with the return value of 15. This becomes 21, and then I return 21 right here. And then I do the math, we get 28. I return 28 right here. Yes, I should have used another number other than 10. I agree with all of you. And then we do 36. We return 36 here. Do the math, we get 45. I return 45 right here. 45. I do the math, and I get 55. And I return 55 right there. All right. Now, what does this recursive function do? Right? Well, it sums up all the numbers from 1 to 10. That's what it did. Right? And so you guys probably know another way where you can sum up all the numbers from 1 to 10 using a for loop and a counter. But if you compare the calculations done using the for loop method and the number of calculations done using the recursive method requires less lines of code needs to be executed to get the job done. So that's why we have recursion, not because it's to make AP students' heads spin. It's because they are more effective, more elegant, require less executions of lines of code to get the job done. That's why we need to know about them. All right. So you're not expected to know how to create a recursive algorithm, because that takes some experience, right? But you are required to know how to calculate out what the result of a recursive algorithm will be, and I think I just demonstrated how you can do that, right? And so let me go back in time and run the program to see that what I just said was actually all true, and that we do get a printout of 55. Okay, so what we were here, we were k, right here we were k, right here we were k, and this is k minus 1. So let me go ahead and run that guy. No errors, running main, and I get 55.